All right, we're looking at building the foundations of the final use of the del operator that we will cover in this course, and that would be the curl, which is the cross product between the del operator and our vector field. And just like with divergence, we used a regular dot product. With curl, we're using a regular cross product. And so just remember that nabla is a vector that holds in the x component the derivative with respect to x, and the y component the derivative with respect to y, and then the z component the derivative with respect to z. And so for curl, last time we were looking at things going in and coming out of a small infinitesimal. It doesn't need to be infinitesimal, but we're kind of treating it that way. So before divergence had more to do with lines that were perpendicular to the surface, and that was more about what divergence was about. Well, with curl, we're a lot more interested in field lines that are parallel to our surface. So in other words, curl is going to measure the amount of spin that's being put on some location. Here, this would be a negative curl. The reason why is because if you use the right hand rule, you curl your fingers in the direction of the motion of the field, and your thumb points into the board, so that would be negative curl. If we drew the arrows the other way, likewise, that would be positive curl. So this is pointing out of the board, it's positive. And of course, if you have lines all just going out perpendicular, there's no twisting motion being caused by that field now, and so the curl would be 0. And that is, this is going to lead us right into deriving Green's theorem, and then is also going to help us with Stokes' theorem. So looking forward to those, and I'll see you then.